Hello students, welcome to Saurabh Sir's classes. So in today's video, we'll be solving a question of mathematical statistics. So the question goes like this. Let x and y be independent random variable with the same geometric distribution given by probability x equals to k equals to p into k to the power p q to the power k, which is equals to k equals to 0, 1, 2. Now let z equals to maximum of xy. So now how do we solve it? So we have to find four questions. The first one goes like this. Find the probability distribution of z. Second is find the joint probability distribution of x and z. Now third one is find the conditional probability, that is probability of this for all k equals to k and l equals to 0, 1, 2. And finally, we have to find the conditional probability of probability z equals to l given x equals to k for all k comma l equals to 0, 1, 2. So now what we have to do is first we will do the first one. So the first one goes like this. Number 1 is probability z equals to 1. Probability z equals to 1, which is equals to, from here we can write p q to the power l into 2 minus q to the power l minus q to the power l plus 1, where l belongs to 0, 1, 2. So the probability distribution of z is given by this, which is probability z equals to 1 equals to pq to the power l into 2 minus q to the power l minus q to the power l plus 1. Now we'll do the second one, or so the second one goes like this. Find the joint probability distribution of x and z. So in order to find the joint probability distribution, we have to write probability z equals to l intersection x equals to k, which is equals to 0 if l less than k and 1 minus q to the power k plus 1 given 2 minus q to the power k minus q to the power k plus 1. So it happens only when l equals to k equals to 0, 1, 2. So we can have this, and the third thing which we have to write is p square q to the power k plus 1 if l greater than k equals to 0, 1, 2, comma dot dot dot. So this is the first thing. 0 if l is less than k, 1 minus k to the power k plus 1 divided by 2 minus q to the power k minus q to the power k plus 1, where l equals to k equals to 0, 1, 2, 3, and p square into q to the power k plus 1 if l is greater than k equals to 1 equals to 2. So we have found the joint probability distribution of x and z to be like this. So now we'll go to the third problem. For this we'll take another page. So the third problem goes like this. Probability x equals to k given z equals to 1, which is equals to 0 if l less than k, 1 minus q to the power k plus 1 divided by 2 minus q to the power k minus q to the power k plus 1 if l is equals to k equals to 0, 1, 2, 3, and similarly p q to the power k divided by 2 minus q to the power L minus q to the power L plus 1. This is the case if L is greater than k, which is equals to 0, 1, 2, comma dot dot dot. So here we found the conditional probability where x equals to k given z equals to L for k and L equals to 0, 1, 2 and dot dot dot. Now we have to find, so we are done with these three. Now we have to find the conditional probability of z equals to L given x equals to k for all k and L equals to 1, 0, 1, 2, 3. So how do we do it? For this, solve the number 4 question. We'll write probability z equals to L given x equals to k equals to 0 if L is less than k, 1 minus q to the power k plus 1 if L equals to k equals to 0, 1, 2, comma dot dot dot, and pq to the power k divided by 2 minus q to the power L minus q to the power L plus 1 if L is greater than k, where k is equals to 0, 1, 2, comma dot dot dot. So we have found it to be like this. I'm sorry, this is not the right answer, so we have to just rub it off. It was the case for the earliest previous one. In this case it will be a bit different, so it will be pq to the power L if L is greater than k, which is equals to 0, 1, 2, comma dot dot dot. So we have answered this question as well. So now we'll go to the question paper. So in the question paper it is given, let x and y be independent random variables with same distribution given by this. Let z is a maximum of x comma y. Now we had to find the probability distribution of z. We had to find the probability distribution of x and z. Then finally we had to find the conditional probability of x equals to k given z equals to L and z equals to L given x equals to k for all k and L equals to 0, 1, 2. So we have successfully solved these 4 questions. So we couldn't get into the nitty-gritties of this particular question. So if you want to know more about how do we derive this probability distribution, joint probability distribution, or you have any queries regarding this question or suggestion, I'll be giving you my number, which is 9836793076. You can simply go to this number and WhatsApp me on this number, or you can also go to our website, which is www.sauravsirsclasses.com. There you will find a lot of other videos like this, and you will get a lot of other materials for mathematical statistics related questions. So thank you for watching this video. Have a nice day ahead.